would like to cover. Let me start with explain some basic concepts. So in unique network, NFTs are composed basically of two primary components. First is collections. Everything starts with collections. What is a collection exactly? So consider a collection as a container for NFTs. Each collection can hold multiple NFT tokens, and it provides some structure to manage them. Each collection comes with its own unique ID, and which is how to distinguish this collection from different collections.
Can I jump in, Max?
In addition, it contains some. Yeah,
Can
sure.
I jump in with one comment? So most of you will probably be used to the concept of having a contract, which actually defines a collection. There's a difference between that approach, which is the Ethereum side of the approach, to the one we do in unique, essentially because what we actually have in the unique network is the contract hidden away from you with a WebAssembly contract that exists at blockchain level. So when we say creating a collection, we are in fact doing it through a contract, but this contract is actually hidden away from you. You don't have to write it, you just need to invoke it and call it, and it's very flexible. So this is what we mean when we say it is the core container for the NFTs. Please continue, Max.
Yeah, okay. What metadata are stored on the collection level? So first is immutable data, such as name, description, symbol, something like that. That data cannot be changed once it's set. Next, each collection has owner. Owner is the address that minted this collection, and some list of admins that could be set during this process of managing this collection. Also, collection stores some collection level properties. That's basically key value pairs. You can store some arbitrary data on these properties, and collection manage list of token level properties. That means that these properties will be set for individual tokens, and along with the permission that dictate who can change these properties. Also, some various constraints and limits. For example, who can nest in this collection, who can burn tokens, who can transfer ownership, and so on. And yeah, basically that's it. Also, we have different modes for collections. It could be NFT, fungible, refundable collections, but let's focus on the fungible collection, or non-fungible collection, on NFTs.
I want to jump in here, Max, to say something phenomenal. Take a notice of this very kind of strange thing that you don't actually see on other chains. You can have a collection of fungible tokens. That is so weird in a sense that what you're doing when you're creating a collection of fungible tokens is you're creating an emission of fungible tokens. It's that easy in unique network, but we won't focus on those. We'll be focusing only on non-fungible tokens here. So here we go.
So, okay, speaking about tokens, about NFT tokens. What metadata is stored on the token level? So it's ID, that is just sequential number, and the full ID of token consists of collection ID and token ID. That's how you can uniquely identify each token. Also, token has owner, the address that owns a specific token, and again, a bunch of properties. Again, it's just key value pairs that define various attributes and characteristics of this token. You can store any arbitrary data on these properties.
Max, if I can jump in, and we'll see it when we get into the detail, but take note, arbitrary data, that means essentially you have the complete freedom of what you want to declare in an NFT and what the structure of this metadata is and the data is going to be. And this is what Max is going to show us now.
Okay, owner and ID of collection, quite obvious things. So what makes token unique? It's properties. So how does it look like on a core level, on a blockchain level? It's just like on the screen, just property key and some value, property key and value. The concept like quite straightforward. But here is the challenge, how to explain some applications like wallets and other applications, how to properly display this data. For example, how to display image. Someone wants to store this data in, I don't know, image property. Someone maybe would like to store it in some kind of different property. So we need some agreements and some standards. And on unique network, we have such agreement. We have such standard called unique schema. Currently, it's on 2.0 version. And this standard introduced new concept of attributes. So attributes.
If I can jump in, Max. So what we're saying here is essentially the schema that we're proposing. It doesn't actually impose any limitations to what a data structure can be. We're just saying, well, we propose that this kind of formatting of the data might be helpful if you want to have a common ground for sharing NFTs. That is saying that if our marketplace is going to follow Schema 2.0, then that is a way to guarantee that any NFT that you create following the Schema 2.0 and the recommended key value pairs, the marketplace will be able to some extent to display it. Now, this is very, very important because for some cases, for example, in the multi-asset cases of unique NFTs, because we can support multiple assets in one NFT, this might become very important at the application level. And now Max is kind of going to go into this application level aspect of organizing data.
Yeah, right. So if properties exist on the blockchain level, it's actually part of like blockchain core. The attributes is at application level or like logic level. We store all the data, all data related to the attributes, all the token data stored on this property that should have name token data, and you store some bunch of attributes there that should follow this structure. It should have trait type that is, again, whatever you want to. It could be name, description, age, nickname, whatever you want, and value of this attribute. Again, this is arbitrary. That is up to you what to store on these attributes. So still, this if you require some additional application specific information for your kind of internal processes, you can still use plain properties, but these properties will probably not displayed correctly on this, on all these wallets and marketplaces. This is just for your application. Feel free to use them. One very important thing, properties can be mutated. So if we make some steps back, we can set token properties and their permission on the collection level. That's what this one slide. So we set list of token level and properties and their permissions. So we can specify if this property can be mutated or not, and who can mutate this property. There are two options. It can be mutated by the token owner or collection admin. That's collection owner and list of collection admins can mutate this property if it's specified.
So let me jump in, Max. One note, that a question that might come to your mind is like, wait, are you talking about access control lists? Well, it isn't actually that fine-grained. There is a list of essentially addresses or a certain list of users that can be declared to be the administrators of the NFT token. And in this game, we're using that property to give those rights to the application. So essentially, it just comes down to naming who can change what in the structure of the property list. And we'll show a bit later on how you do it practically.
Right. Yeah. One more concept, nesting. This also will be useful for this for your submissions. You can actually create some tree structure on your application where your NFTs owns and other NFTs. So it will be some kind of tree structure of this. When the end user owns NFT, this NFT owns another NFT, and so on. This is called nesting. And how nesting works? Nesting works due to the mapping mechanism between token ID and address. So again, we have this unique token ID that consists of collection ID and token ID, and this token ID can be mapped to the Ethereum address. So if token owned by this address, this creates this bundle structure when the token owned by the another token. And the last point I want to mention.
Max, can I jump in just with the one comment regarding this? Now, remember, if you're coming from the Ethereum side, it's kind of quite natural to think that you would need to create some kind of contract which would resolve the question of nesting, right? But this is not so unique. Again, nesting happens at the blockchain level. Why and how is Max kind of showed you the hint to it, because you can use the token ID and collection ID to create a unique address. The object, the NFT object, becomes an addressable object in the block space. When it becomes an addressable object, it simply means that you can address something to it, which means you can send something to it. And this is the simplicity of how nesting is accomplished. What you're actually doing is sending an NFT to an NFT, and the receiving NFT is behaving as though it's a wallet. It receives an NFT, and then it owns an NFT, and the NFT that is laid within that receiving NFT becomes the child, and the one that receives it becomes the parent. And this is the basis for forming binary structures, because then you can nest several NFTs into one NFT, and those several NFTs at layer one can then have further nesting. This is the simplicity of the concept, and why there is no special code that you need to consider or even think up and create to just have this possibility. It comes out of the box with the blockchain itself.
Okay, yeah, right. So we prepared some code examples. You can use them to bootstrap your projects, and let me go through these examples. So first, you will need to perform some actions. You need to create your Substrate account. I believe you should know how to do it. If not, just ask us. We will provide you information. You can get our OPL tokens, that is testnet tokens, for free using our faucet bot. And just create an example and .env file from env example, and set your mnemonic phrase there, just npm style, and yeah, you're good to go. So the legend is we create some game that consists of two collections. First collection is car collection, and it contains some. Every token will have its nickname and some statistics like victories and defeats. When this token competes against another token, if it wins, victories is incremented. If it loses, defeats incremented. So yeah, as I said, players can compete against each other. And one more thing, when token achieve something, for example, for the first win, we will drop some achievement NFTs that will be stored on this nesting, on this bundle structure. So actually, your car will own this achievement NFT. So
Max, before you continue, I need to jump in just to say, like, what we're laying out here is like we've thought of a hypothetical game, right? So we're going to make it as simple as possible to show you with this layout, like you have a player and a car, and we'll have some simple, really simple concept of game, which Max is explaining, to show you how the game logic fits in with actually applying NFTs in the context of fitting it to a game, right? So this is the layout for this hypothetical game. Like you will have yours, of course, which has a completely different concept, but this is the idea we're trying to portray here.
yeah, right. So in this code example, we have only 4 scripts. First 2 scripts just to create first collection, for the collection of cars, and the second collection of achievements. The third script is about creating car NFTs, and the last script is about game itself. It handles some game logic. It's quite silly, so we just randomly select one of the winner, but it's explain how it works. So let me go through these scripts. First, script of collection creation. We have these utility scripts. You should also go through these code examples, but they very easy. So
they're easy, but they explain a core concept of how, just don't skip over them. They go through a very interesting concept that you need to figure out, which is like, how do you actually connect? How do you create a connection between a wallet and a browser and a substrate account and the application, which then allows the application to have the essentially the right to the substrate, that is, make extrinsic calls and make them happen through the application.
Yeah. So yes, let's go to the collection creation script. It's very simple. So we use our SDK to create this collection, and as I mentioned in presentation, we just set some required properties like name, description, and token symbol. We also want to set cover image for this collection. And here's important thing. So first, because we need to set achievements for this collection, we need explicitly set nesting permission for this collection. That's how we do it. We set this permission, and we want to restrict this permission to collection administrator only. So the user cannot create these bundles on its own. Just the application can do it. Next,
collection admin here, implying that we'll be using the collection admin as the application.
Yeah, right. So other important thing, as I mentioned, we store our attributes on the token data property. So we will rewrite this permission for this property so that only collection admin can mutate this property, but token owner can't. And basically that's it, very simple. So let's do it. Let's go through this example. I prepared the scripts, and let's just run it.
Oh, and by the way, there is one point that we will not be covering here and is part of the challenge. As it is implied, of course, when you create the NFT properties, some of them you might want to be accessible to the user, that is, that readable, so that anyone that looks at the collection properties finds out like what is the, I don't know, the score, the number of races and so on. And there might be some properties that you want to hide. And this you can play around. And if you wish to accomplish this, just create a solution of how would you then hide the data within the data structure so that it's not accessible to the user or the general as data on the blockchain, but only accessible through the application. That's kind of an extra.
Yeah, right. So let me share my entire screen. So that's how my collection looks like. So we create this collection of cars. They do not have any tokens yet, but this is metadata. Let's go next and create another collection for achievements. We also have this script. It needs a couple of, like, about maybe around 15 seconds to mine this transaction. So let's wait a bit.
By the way, we are creating this in real time now. This is not prepared collections. Like Max is currently minting live all the elements. So this should be your experience in real life when you recreate these steps.
Yeah, right. So again, here's our achievement collections. And now we would like to create two tokens that will be car tokens, and here's another script. So while this script means tokens, let me go through the script. This script about creating NFTs.
Oh yes, let's see the data structure. Right, that's the juicy part.
Yeah, this one not very interesting, but here's our script of creating this token. So we set 3 attributes, and this is very simple. It's just we run this method that creates a token. It requires collection ID. We set image for this token, and we set the owner of this token. Owner is just some random address. We don't want to have an ownership for this demonstration purposes, so we set some random addresses for the owner. And yeah, here's 3 attributes: nickname, victories, and
to clarify that, random addresses, because we're just making an example. In real life, those wouldn't be random addresses. That would be the user addresses that have logged into the game. A clarification there, yeah.
Yeah, right. So again, it's very simple: victories, defeats, and these 2 properties we are going to mutate during the game logic. And
it's again, that simple. That really looks like a very, very basic JSON structure there. So this is what we've kind of provided with Schema 2.0. In Schema 1.0, it used to be quite complicated. It's really easy now, that easy. You just make a list, attributes, the name of the distribute, the value, blah, 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 structure it the way you want it. And of course, you have to untangle it yourself after that because you're creating the structure, but declaring it has become this simple JSON style of laying out what you want to be the data in the NFT.
Yeah, right. So here's how our NFTs looks like. We have nickname, and currently it have like empty stats, no defeats, no victories. The same for the token, for other token. Let's do. Yeah, different card. Still no defeats, no victories. Okay, let's do it. Let's play the game. So this script, final script, contains logic that you can use in your application. This shows how can you mutate properties of your NFTs. It's also very, very simple. So here we randomly select winner. It's not very interesting game, but still. And here's 4 scripts. First script sets victories to winner. It increments victories property for the winner. Second script, this one, it's just checks if this is the first winner for this token. It creates achievement for this token, and 2 more scripts for user. First one increments defeats for the token that lose this race, and this second script means achievement for the first lost game. very simple again. So you just call this SDK token, create for the nested token, and you have to specify address, and we have some utility functions that you can use to set the owner of this achievement token. And this will be the token itself, the token of the.
So one interesting concept here that I would really like to point out is very, very kind of intuitive, but you can miss it. You actually, when you mint and when you assign these tokens, you mint them to the destination address. So it's not a two-step process where you kind of, as an owner that is not the future owner of the NFT or the whatever the prize is, you don't first create it and then form some kind of escrow and then airdrop it to them. No, you do it in one step. You declare that you will be minting a token, and you declare to what address you will be minting it. So there's no in-between step, and that really simplifies the process of this from the game side, of not having any intermediary steps where you're kind of saying, yeah, but you know, if you kind of minted in one place, then what's to guarantee that, you know, there'll be a transfer from one address to the other? No, this way you skip it completely. You just point at the address and it goes through a contract directly to the destination wallet.
Yeah, right. So now we run this game against two random tokens. I think I set wrong tokens because it was card number 18 and second one was, I believe, number 19. But no, I don't think it's very important. Okay, that's it. We select the winner and let's see what happens. Yeah, right. I accidentally set wrong tokens, but the idea is simple. So this token has victories and it's incremented, and also it has defeats. It's also incremented for this token. Currently, it's the winner is 1. Let's actually set correct data to see how achievements will be granted for this token. So we created token number. Let me see. It was. Sure. It was card number 18 and card number 17. Let's build this card number 18 and card number 17. Yeah, again, we randomly selected this winner, and the winner is card number 17. And so that this card loses this race, we have to wait.
Yeah, the tokens get updated. Let's see how fast our blockchain reflects it, right? Very quickly.
Yeah, correct. So the number of defeats increased, and also our token received this achievement token for the first losing game. And for the token number.
An achievement for losing. How does that work? No, okay, yes. Okay. It doesn't matter. It's the demonstration of the logic is like very simple from this point of kind of, it doesn't matter that it lost. It's just that very simple how to address this achievement NFT to it by simply nesting it, right? So you have complete freedom to work out any combination of solutions or ideas you might have. You can even nest achievements within achievements and have some kind of crazy structure like that. That's all up to you.
Yeah, right. So card number 17 won this game, so it has 1 victory and also received achievement for the first win.
So that's an achievement there.
Yeah. So also you can set some like bonuses for these achievements. For example, for this first win, we have bonus of 10, and you can, for example, you can easily receive all the bundle using our SDK, and you can, for example, sum this bonus and create like more powerful token that will win more races. It will be faster, maybe accelerate faster, something like that. Any logic you would like to implement is possible. So basically, that's it. One more thing. So let me open this presentation. We have these useful links here, and again, here's the link for the demo. Oops, let's close. I don't know what to say. Okay, right. We also have this documentation that explains all the concepts, how to start working with SDK, how to work with accounts and wallets. And it has a section that explains how Schema 2.0 works. And also we have this React boilerplate code that can help you bootstrap your project. It already has SDK connected to this React boilerplate and some tokens like Polkadot.js and MetaMask already connected here. So just try it out, and you can.
This being a question of how actually you can connect what we previously mentioned. Like if you have a browser and you want to connect a Polkadot.js wallet or a MetaMask wallet, how it's all in the boilerplate, so you don't have to figure it out. It's just copy paste parts that you need and apply whatever approach you're going to be making there. Of course, it works with other wallets as well. Yeah, does it? I mean, that would be just a simple replacement of address, right,
yeah,
Max?
Right. Yeah, right. So basically, that's it. I don't know what next.
Great, we've got 2 minutes left. I mean, we made it like in time. Hooray! Perfect. I hope everybody was engaged with this kind of presentation. I hope it was fluid, that you could kind of follow through. We need to provide these links for you. We'll get in touch with the organizers to make it accessible. Max, can you make it visible on the screen if anybody wants to jot it down or snapshot it for now, if they immediately want to stand up and start working on it? But we'll provide these as well. So that should give you all the elements you need to successfully implement some kind of NFT in whichever race game you might have functioning at this point. So there you go. I hope that was helpful. Really do. Keeping our fingers crossed.
Thank you very much, Philip. Thank you very much, Max. That was an amazing workshop. Fantastic. Thank you.
Thank you.